good morning, good afternoon, good evening. Whatever be the time you are watching this video, let us welcome you all to this channel Future Endeavors, which is devoted to all of you, is channel devoted to science. First of all, before beginning today's lecture, I would like to thank you all for supporting our channel and inspiring us to post more videos like this. Now, to begin it, we are discussing about the chapter Units and Measurements, which is a part of the class 9 syllabus. In the previous classes, we have discussed about physical quantity, their types, and also we have discussed about the system of units including the SI units. Now today, in the last class we have concluded that when you use the various units, it is not possible to use the same unit everywhere. But what I want to mean is that, say you want to measure the length of a road. Now see, the length of road, the SI unit of length is meter. However, if I say that the length of a road, if I express that length of a road in meter, say the distance of a certain place from another place is, I am saying that it is 10,000 meters. It is quite odd. So rather we will not use the unit meter there. What we use? We will use a meter, unit kilometer, instead of using the unit meter. Now what is the relation between this kilometer and meter? To understand this or to memorize this, you need a chart which shows the various multiples and submultiples of units. So for today, let us make the heading multiples and submultiples of units. Multiples. So first of all, these are the multiples of units. So I will be writing the various multiples of units that you use in our day-to-day physical measurements. I would rather give it out in a chart so that it is easier for you to keep it in mind. Now see, what are the various multiples of units that we use? To begin it, so the first multiple that we use, so see, these multiples or submultiples can be used as, not used as, it is used as the prefixes with the units. So let us see what are the multiples. I will just describe it. So first multiple is deca. Symbol is dA. It is a value of 10 to the power 1. Second is hecto. Symbol is H. It is 10 to the power 2. Third is kilo. Symbol is small k. It's 10 to the power 3. Fourth one is mega. Symbol is capital M. It is 10 to the power 6. Fifth one is, after mega comes giga. Symbol is capital G. It is 10 to the power 9. Then comes sixth one is tera. It's denoted by the symbol capital T. 10 to the power has a value of 10 to the power 12. Then seventh one that comes is peta. PETA. Symbol is capital P. It is 10 to the power, value is 10 to the power 15. Then comes the eighth one. Eighth one is the exa. Symbol is capital E, 10 to the power 18. Ninth one, after exa, so deca, hecta, hecto, kilo, mega, giga, tera, exa, peta, then exa, then comes zota, capital Z. It is 10 to the power 21. And the last that is now in use is iota. capital Y. It is 10 to the power 24. So these are the 10 multiples of units that we use in our day-to-day life or in our daily various measurements of physical quantities. So please note it down and try to remember this. Okay, I hope quite a few you are accustomed with quite a few of the multiples like deca, hecto, kilo, mega, giga and tera are also very common to you, because nowadays the memories that you have in your laptops, computers or smartphones, they have the memory in terms of gigabyte, terabyte, so it is quite familiar to you. So I think these last four are a bit new to you, but if you just go through the table or chart a few times, you will be accustomed with these units or these multiples of units. Okay, so I think you have noted it down. Okay, now let us move on to the sub-multiples of units. Sub-multiple of units. So what are the sub-multiples? Let us see. Sub-multiples. What are the sub-multiples? Let us see. Sub-multiples. So next comes the sub-multiples. So I will just put out a letter sub. The remaining thing will be same. Sub-multiples of units. So let us see what are the various sub-multiples of units. To begin with, number one is deci. Symbol is small d, x 10 to the power minus 1. Second one, after deci comes the centi. Okay, symbol is small c, is 10 to the power minus 2. Okay, then third one comes the milli. Milli, symbol is small m, it is 10 to the power minus 3. Fourth one comes the micro. It is represented by a letter or rather say symbol mu. It is not u. Please be careful. This is not u. Rather, it is mu. It is a symbol. Its value is 10 to the power minus 6. Fifth one, after micro comes nano. Small n. It is 10 to the power minus 9. Sixth one, after nano comes the pico. Symbol is small p. It is 10 to the power minus 12. Next comes the seventh one. After pico comes femto. F. It is 10 to the power minus 15. Then after femto, what is the sub-multiple? Atto. Small a, it is 10 to the power minus 18. Ninth one is zepto. It is small z, 10 to the power minus 21. And the 10th one is yocto or small y. It is 10 to the power minus 24. So these are the various sub-multiples of units that we can use in our measurements. Like I said, that if you want to measure the, rather if I take the example, whether if you want to measure the mass of a heavy vehicle, so would you express the mass of that vehicle in grams? No, I don't think so, because if you express it in grams, you have to add on many zeros after the value. Suppose I say, okay, just let us take an example. I think you have noted the sum multiples of units. I'll just give you one or two examples so that this use of these multiple and sum multiples of units are clear to you. So let us move on to the example. Okay, so you have noted it down. Okay, so if you have not noted it, please pause the video. You have the option to pause the video. You can pause it and note down the chart. Again, I am saying that many of these terms are new to you, but if you go through this chart 4 to 5 times, you will be quite familiar or accustomed to these terms. Okay, so let us see why do we use this? Why do we use these multiples or submultiples? See, if I say that the mass of an object is, let's say I am saying 1, 5, 2, then 1, 2, 3, 4, 5, 6, this much gram. Okay, this much gram. So, is it very convenient to write it in this way? You are writing 152, then you are adding say 1, 2, 3, 4, 5, 6 zeros. While writing so many zeros, the chances of mistakes rises. You may accidentally write 5 zeros instead of 6 zeros, so your expression will be wrong. So rather I should not express it in this way. I can use a higher unit of the gram. That is, I can write this or express this as in kilogram. Then if I express this in kilogram, we have seen that when I kilo is related to the gram as 10 to the power 3. So I know that 1 kilogram is actually 10 to the power 3 grams. Okay, so here if I express this in kilogram, I will be writing it as 152. So my 3 zeros will be removed, this much kg. Still, if you are feeling it inconvenient to express this in kg, I can remove these 3 zeros also. Okay, we have seen that the next higher unit, that is the next higher multiple after kilo is mega. So I can obviously write this as 152 megagram. No problem, you can write it. So in this way, we use the various multiples and submultiples to express the various physical quantities as and when required. Okay, fine. So I think this submultiple and multiples of units are quite clear to you now, and you are also familiar with the system of units, specifically the SI system of units. If you have not seen our previous videos, you can just go through our channel and watch those previous videos. So you will be having a clear knowledge about the SI units or the various other classifications of physical quantities, etc., etc. So now moving on to the next topic. The next topic that we will be discussing today is order of magnitude. So what is order of magnitude? Let us see. Order of magnitude. Order of magnitude. So what is this order of magnitude? See, when you need to compare between two quantities, two physical quantities, say we want to compare the masses of two objects. Okay, so I take an example. So mass of one object is, say rather, it is 5.3 into 10 to the power 7. So I write as kg. Okay, and the mass of another object is, say, it will be 4.9 into 10 to the power 9 kg. Okay, so now see, when you compare these masses, this 5.3 or 4.9 is very small in comparison to 10 to the power 7 or 10 to the power 9. So actually, while comparing these two masses M1 and M2, we may just omit this part. We can make the comparison just by seeing this power of tens. Okay, you can just see, just if I say the mass of one of this 10 to the power 7 kg and another is 10 to the power 9 kg. Does this 5.3 or 4.9 make any huge difference? No. I just can compare those quantities by seeing the powers of tens only. So from this I can easily say that yes, it is one is 10 to the power 7 kg, one is 10 to the power 9 kg. Obviously, I can say that M2 is greater than M1. So I don't need to see the numerical values. Now, what is the order of magnitude? So I think a slight idea has been created in your mind about the order of magnitude. So I can say that order of magnitude is actually the power of the 10, present in a physical quantity. Now it is not that easy that you can just take up any physical quantity, express in any way, and just see what are the number of what is the power of the 10, and you just mention the order of magnitude. No, it is not that way. So just let us look at about a formal expression of this order of magnitude. So I may just erase it. While expressing the order of magnitude, I can say, I can write it like this. In order to get the order of magnitude, you have to express any physical quantity in this form: n into 10 to the power m. Okay. In order to get the order of magnitude or determine the order of magnitude of any physical quantity, you have to express any physical quantity as n into 10 to the power m, where n can be any positive integer value between 1 to 9. Okay, and your m is the order of magnitude. Only when you express the physical quantity in this form, then only the power of the 10 that you are getting is the order of magnitude of that particular physical quantity. So I think you have got a fair idea of the order of magnitude. Okay. Now, how to determine the order of magnitude? I will just show you with some examples that how we can calculate the order of magnitude. See, I think you have noted it down. I will be erasing it off. Okay. Say I take a physical quantity. Say again I am taking mass of an object. I am referring to the mass of an object. Okay. So let us see. I have mass of an object m equals to what I can say mass of an object. So let us say 625. Okay. 3 into 10 to the power 5 kg. Okay, so now see, many of you will be thinking that in this physical quantity the order of magnitude is 5. No, this is wrong. As because you have not expressed the numerical value as we have mentioned earlier. See, here it is 6253. This is not an integer value between 1 to 9. First of all, you have to express this in between 1 to 9. So let us see how we can do that. I can just divide this number 6253 by 10 to the power 3 minus 1000, so that the point comes to this place. Okay, and here I have to multiply another 10 to the power 3 kg. Okay, so this value becomes 6.253 into 10 to the power 8 kg. Okay, is it clear? Fine, good. Now you have expressed the physical quantity in that form, n into 10 to the power m, where n is an integer value between 1 to 9. Okay, fine. So you will be saying, okay, we have obtained that expression. Then the order of magnitude as it can be seen on the board will be given as 8. So is it correct? Again, this is slightly wrong. Why I am saying this slightly wrong? This is because we have to remember another step. See, this number, when this number n, so I may just write it at the top. Okay, I'm just writing at the top. If the okay, first let me just erase it. Let me just erase it. Okay. See, if I get that the value of n, please note it down, if the value of n is greater than 3.2, greater than 3.2, just note it, greater than 3.2, then increase the power of 10 by 1. Okay, means add 1 with it. And if n is less than equal to 3.2, then keep the power of 10 as it is. Okay, so please remember these two rules, that if it is more than 3.2, then increase the power of 10 by 1, and if it is less than or equal to 3.2, just keep the power of 10 as it is. I'll just briefly take one example now. I think you have noted it down. If not, please pause the video and note it. I'm just erasing it off. I'll be taking another two examples to make this point clear to you. Let us see. If I have a quantity, again I am taking that mass. If I have a quantity m equals to 2.9 into 10 to the power 4 kg, then here order of magnitude, I'm just writing it as order of, okay, let me write order of magnitude is equal to 4. Okay, as because this number is 2.9, which is less than this is less than 3.2. So obviously I have not increased the power, just kept it as 4. So order of magnitude is 4. If I have another mass, so this is m1. If I have another mass, m2 equals to 5.5 into 10 to the power 6 kg, then order of magnitude will be equal to 6 plus 1, that is equals to 7. We have incremented the power by 1 as this number is greater than 3.2. Okay, so it's clear to you all. So I hope the order of magnitude part is clear to you, and I think you will be having no problem now in order to find out or determine the order of magnitude. And remember, while comparing into physical quantities, generally we take the order of magnitude. We don't see the numerical value. Just the order of magnitude is enough to compare two quantities. Okay, so I think we will end our lecture here. The first chapter of your class 9 syllabus is over. We will move on to the next chapter. Till then, I will be thanking you all. But before leaving the video or lecture, please, I am again thanking you all for supporting us. Please do watch our video, like it, share the video, subscribe the channel, and please press the bell icon so that you can get the notifications when these videos are uploaded. And also please do mention your comments. If you have any query, you can also mail us at the given mail ID. So till then, till the next class, thank you, bye bye.